Hi, this is Linda Noss, and this is the 5th video in the sorting series. This video is on insertion sort, and the insertion sort is, if we go to Wiki, you'll see it's right there. Again, it has a really good little animation right over here. It kind of explains to you what the algorithm is, and here's the best and the worst. Kind of shows you here how it works. So basically what happens is it starts with the first element. It says, okay, if it's just the first element, it's in order. So that if you ignore everything else after that, the 3 is in order. Then it goes to 7 and it says, is 3, 7 in order? And it says, yeah, it is. Then it goes to 4, and 4 is placed in the proper place. So 4 looks at 7 and says, oh, I got to flip that. Then it looks at 3 and it says, no, I don't got to flip that. So it flipped with the 7, but then it didn't flip with the 3. Then it goes to the 4th element and places that one in the right place, which is 9. Then it goes to the 5th element, which is 5, and says, okay, 5 is less than 9, so I got to flip that, and 5 is less than 7, and I got to go that. And then it doesn't do the 4 or the 3. So what the assumption is that if I'm sitting on 5, for instance, it assumes that everything that came before that is in order. So these are all in order. And now I'm looking at this one. I'm going to pick this one up and put it where it belongs. And then you pick up the 2 and put that one where it belongs. And then you pick up the 6 and put that one where it belongs, which is right over here. So that's basically how it goes. So I have 2 versions of the program here. I'm going to go through with you. The insertion sort. So basically, I have my little array here. I have my temporary variable because you know I'm going to have to do a flip. I know I'm going to have a loop, so I have an integer I. And then I just start looking at the first. So I started by just looking at the first and the second element. Now, if I have the first and the second element and they're out of order, which is this right here, that means I got to flip them around. Okay, so that's what this one does right here. So it just flips the first and second one around. And then then I go to the next one, knowing the first and second one are in the right order. Okay, then I can go on to the 3rd element and say, okay, I look at the 3rd element and I say, well, if the 3rd element is smaller than the 2nd element, I have to flip that one around. And then so now the 2nd element just became the 1st element. So then if the 1st element is smaller than the 1st element, then I got to flip those around. You'll notice that this right here is the same as this up here. So it can be done recursively. That's not the way we're going to do it today, but we can look at that when we do recursion. So essentially, this is the same as that. And I could go on. I could say, okay, now look at the 3rd one. The 3rd one is greater than the 2nd one. Then flip those around. Then you got to look at the 2nd to the 1st, and then you go. So essentially, I can take this whole set of code right here and rewrite it again down here, and just add another if statement on top of it. And then I can do the next one and the next one and the next one. So obviously this is not the best way to do this. So what we're going to do is we're going to take this entire thing and we're going to put it in a loop. And this is what it comes out to be. Okay, so here is the piece I kind of just did. I have a few extra things in here, which I'll talk about. But essentially I have this one right here. Okay, and you'll notice that I'm doing something a little bit different. In previous sorts, I did, basically, I did an I and an I plus 1. In this sort, I'm choosing to make I the greater of the 2. So I'm going to, because you'll see in the one that I hand wrote, it's 1 and 0, and then 2 and 1, and then again 1 and 0. So what I'm going to do here is I'm going to say I and I minus 1. And the neat thing about that is I can go from 1 up here to the length of the array and not be out of bounds. So I is equal to 1, so I'm comparing it to 0. And if those two are out of order, then I flip them. And then I go back up and around, and now I is equal to 2, so now I'm looking at 2 and comparing it to 1, and if those two are out of order, then I flip them. Then it goes back up, and I start with 3, and so forth and so on. So I do the same thing over and over again until they're all in order. You can see down here they are in order. So let's just see what I did here. So basically, if I got rid of these right here, these are all things we haven't talked about yet. See if I can do this. Not messing it up too bad. And save it. And you can see it puts the first one, it's not really swapping any of them. It didn't put any of them in order. Oh, it did flip the first two around because that's all it looked at was the first two. Okay, so essentially what you have to do is you have to have a loop again on the outside. So I chose the do loop. I did that for a reason. So the do loop now will take me from, I start J at 0, and I immediately add 1 on there. So now I'm starting with J equals 1, and I'm going to compare. See, this one works fine, I think. Click OK, and you can see it puts them all in order down here. So J is starting at 1, and what it does is it takes this right here, it goes 0, 1, 2, 1, 0, 2, 1, 3, 2, 4, 4, 3. So it makes it go around and around and around. And that works pretty good. And you can see when I run this, it says 0 swaps. Oh, because of my swaps is off. So basically I put a little swapping counter in there. I saw swaps at 0. And every time I swapped, I just put a swap plus plus in there, which tells me how many times I actually use this little swapping algorithm here. And you can see when I run this, it's actually 22 swaps to get this in place. So my question was, what happens if everything, if everything gets in order earlier? So basically, I'm comparing these two and swapping them, and then compare these two, swap them, and those two swap them. Then these two swap them, these two swap them, these two swap them. What happens if along the lines in there, everything is in order? And I never actually use this algorithm here. It just never happens, which means everything will be in order. So I put a little boolean in there, set equal to false, called switches. And then if I swap out two things, then I set that equal to true. So the last piece is, I don't want to go just while I get to the end of the, while I'm not at the end of the very array. I also want to stop if the switch is false. So if this is true, if I did switch and I'm not at the end of my array, I'm going to keep going. If either one of these conditions is false, the whole thing falls apart. So essentially, you can see right now I'm at swaps 22, and by just adding that one piece in, it brings it all the way down to 10. So that's really good, because if stuff is already in order, there's no reason to flip it. So that kind of keeps you from, that's a more efficient way of doing this. So the last thing I really wanted to do here was I just want to look at all the different sorts we did. I'm using the same array in each sort. So we did this sort here, and it turned out to be 10. And when I do my bubble sort, you can see I have the same array here. I have swaps, I have 22 swaps, same as the other one without the switch in there. And I have a switch in here. So maybe I'm not using it correctly, but I think I am. While switched, yeah. And then over here, I have my selection sort, same array. And when I run this thing, you can see the swaps is 12. So I only swapped out 12 here. So the insertion sort can be a lot more efficient. So go ahead and try your insertion sort and see what you come up with. Hopefully this, as you do it, you'll understand it a little bit more. And I'll get back to you next time. Thanks.